So when we talk about wireless networks, we are going to look at the various wireless network attacks and of course how we can defend these kind of attacks. And better still, we are going to look at maybe how to use some tools, right? These tools are free. You can always download them and maybe use them to guard your network, or rather you can still use them to exploit other networks. So the concept of wireless networks cuts across different things. So we're going to look at maybe some basic technology that are found within a wireless network. Also, you need to maybe look at the various network protocols, as I mentioned, wireless network protocols that you can always use, and those ones are actually the WEP. They're the technologies that are used here, right? And of course, the defense techniques, and of course, we're also going to look at the war driving, right? This is how the attack on the wireless network happens, and some tools that hackers and you, as a professional, can be able to use, right? So, what is a wireless network? Basically, are unguided kind of networks. Unguided simply means you use the wireless media to communicate. That means you don't need to use what? The physical link, or rather the cables. So when you're using Bluetooth, that is an example of wireless network. When you're using a Wi-Fi, that is an example of wireless network, right? Why do you need it? Of course, people need to move around, right, for mobility purposes. So with your phone, you can always access some kind of wireless network. So you'll always be moving around. So you don't need to be tied to a particular cable, right? So this mobility aspect actually creates another conducive environment for attacks, because you'll be moving from one wireless network to the other using the same device. You see, with the wired network is a bit different, because once you are within an organization, you can secure that, right? But if you have wireless devices that you keep on moving around with them, it's like you're moving target. So it also brings on board some kind of challenges when it comes to security, right? So we had already looked at what security is, so we know what to expect. Security, of course, will enable us maybe avoid being hacked into, for instance, right? So first of all, maybe we need to understand the concepts of wireless network. Components, not concept. Now, components are ideally very basic, such as the access point, right? Access point is a transceiver, as you're going to look at. It could be a router that actually propagates continuous signals, right? You also need to have a wireless network interface card, because this is the card that actually offers a way of configuring our devices into what? A wireless network. Uh, Also, you need, or any other type of wireless network device that you might think of. Better still, at some point, also you just need some 2 or 3 Ethernet cable, just to ensure that you connect the wireless network and also the wired network. Because there's no way that you can say in a given organization that it only relies on wireless devices. No, you'll reach at a point where you need to connect some devices physically. So you kind of need some cable, ideally. Now, wireless network interface card, we all know or understand the network interface card, right? For the Ethernet cable, you can always attach it to the NIC port, right? So for the wireless, ideally you don't need to attach that particular cable. So main function is actually to convert the radio waves. The radio waves, these are continuous signals, right, into digital signals and so on, right? So it actually performs quite a number of functions, right? So that is just one component. The other one is access points. As I mentioned, an access point is a transceiver that can always be able to propagate some wireless signals. Now, an access point typically could be a wireless router, right? So if you have a router, you can always configure it to propagate wireless signals, and that can always act as a what? As an access point, right? So as you have mentioned, not all wireless networks connect to a wired network. So it also acts as a bridge. That's something that I've so far mentioned, right? Between a wireless network and a wired network, right? I don't know if there's a question. Someone is raising their hand. Okay. So basically, one critical task to securing our wireless network is to be able to configure an access point properly. Remember one of the issues we had when you are introducing the concept of network security, we looked at the loopholes, right? Or ensuring that we eradicate vulnerabilities. So if you don't configure your access point properly, then the high chances your network is going to be vulnerable, right? So a basic wireless router could act as an access point. And when you purchase a router, wireless router, such as a D-Link router, it could be a Cisco router, any type of router, first of all, you need to turn off the what? The service set identifier, right? This is a kind of some kind of alphanumeric characters that uniquely identifies what type of wireless network is being used. So normally by default, this particular SSID is normally broadcasted to the entire network, and that's why you can be able to discover that there's a what? That there's a network, there's a wireless network that we have, right? So when you move to a particular point, you'll see that particular. So it normally broadcasts itself, which poses as a very big security threat. So you should also change it. Normally, when you purchase a new wireless router, for example, the manufacturer normally just leaves that particular default SSID. So if I'm a hacker and I've discovered that you're using a D-Link router, and I know the default SSID, I'll simply just hack into that particular wireless network. But if you change this particular SSID, it can be a bit of a challenge, right? So we need to actually change this. So we are still going to look at more of this SID and what it is. Actually, as I'd mentioned, these are service set identifiers, and it consists of some unique alphanumeric characters that are actually configured within that particular router. So you need to change it, as you have already mentioned, when you are launching a new wireless access point. So as I've mentioned, the default SSDs from different manufacturers, in fact, they're just their default name, right? Normally they're just their default name. So if you can say, like, for example, compact device is just a compact, right? So it's very easy to actually log into this particular router and cause some attack, right? Apart from the components, we also need to understand the standards. It's very difficult to talk about wireless security if you don't understand these standards. Now, one particular standard or organization, for that matter, that has so far been able to release these particular wireless standards is the Institute of Electrical and Electronics Engineers, right? A good network student, you should be able to know, like, we have more than 5 organizations. We have the IETF, we have the ISO. These are organizations that are mandated to have some standards that any communicating device should conform to, right? So for the wireless networks, the standard that actually provides the procedures and rules is actually the IEEE. And the first standard is actually the 802.11, right? 802.11 is one of the standards that is actually known for the wireless network. Now, within this particular 802.11 standard, there are other additional projects. So it's just a standard that keeps on growing. So when they realize that they need to update their wireless devices, they create a sub-standard within the main standard. So this is the main standard, right? That's why it is the first wireless technology standard to be implemented. You can see the connectivity was a little bit not good. So it was between 1 Mbps to 2 Mbps within a LAN. Now the key thing is to understand is that this particular standard is applied within the level 2 level 2 layers of the OSI model, or the bottom 2 layers of the OSI model. This one refers to the physical layer and to the data link layer. So they govern the communication between host to host. When you connect to wireless devices, it is this particular protocol that governs this particular communication. So when we talk about wireless communication, we first of all need to understand the 802.11 standard. Now, wireless networks works differently from the wired network. When we talk about, like for example, let's look at the star topologies or the Ethernet topology or network. They normally carry signals, or rather communicate based on the carrier sense multiple access collision detection mechanism, right? That is for the wired network. Wireless network doesn't have that way of or possibility of actually determining how to avoid to detect those particular collisions. So ideally, when two devices are communicating within a wireless network, they normally avoid collision, and that's why this particular protocol brought about the way of communicating by avoiding collision within a wireless network. And that's why we have the carrier sense multiple access collision avoidance. Now those are just some concepts of wireless network. As I mentioned, there are quite a number of projects under the 802.11 standard, as we are going to see. So the first project or improvement was 802.11a, right? So you can see the operation frequency, the speed improved to 5 gigahertz, the throughput also was improved, right? Remember here, a lot of security issues were there, but were not still being handled. At this point, a lot of wireless networks are really being hacked into, right? So there's a new improved version, which is 11b. You can see the range is quite well. The throughput is also good. At this point is where we now started defining the wireless network as Wi-Fi. So we had wireless fidelity, and that's what people are still using up to now. It's only that now the security aspect has been improved. So it allows a lot of channels, and here, because we're talking about wireless security, they introduced a way of securing the wireless network, and this is what we refer to as wired equivalent privacy. We are going to look at it later on, right? So the first approach, or the first attempt towards securing the wireless network, was actually achieved within this particular standard. Then a lot of improvements were made to avoid overlapping of signals, or what we refer to as the crosstalk, right? So 11E was brought about, and of course we had 11G. Now just remember these ones as just improvements of the wireless network that you're having, right? We've moved into 11i, right? Now 11i, unlike 11b, 11i improved a lot in terms of security, and that's why we had the Wi-Fi protected access. So WEP had a lot of vulnerabilities, as you're going to see. It has a lot. It had a lot of issues, which was countered by producing the Wi-Fi protected access. So 11i actually contributed a lot towards improving the security within our wireless networks. And of course, we have 11n, right? So these ones speed were improved for the networks. A lot of devices could be connected. Also, we had 11a C that provided a lot of bands, spatial channels. So there are quite a number of devices that were brought about within 11n. So we had the Netgear routers, the access points, and so on. Still, the project continued. So we had 11AD. So you see, from just the platform of 8.0 to 11, we had a lot of improved projects. So I won't really go into details because we're not really looking at networking as a whole, but these are just standards that were set because we had the wireless network. We also had HyperLAN too. For the Bluetooth also came about. I believe most of us have used Bluetooth devices, right? So we had 802.11.15, sorry, that created a conducive environment for communicating within a personal area network, right? So you can see this gentleman trying to communicate or using something on their ear. But there was we're talking about Bluetooth, right? Bluetooth contributed a lot when it comes to connecting portable devices. I'm aware even at home, even right now, you're using some kind of Bluetooth, right? And it's a very good breakthrough, right? So Bluetooth is actually associated with the 802.11.15 standard. We also had 16 WiMAX. I don't know whether you guys had a chance of using WiMAX. WiMAX is still there, ideally, right? So it's also contributed to use of wireless technologies within a metropolitan area network. We know that metropolitan area network covers a range such as around 100 kilometers, such as a city, right? That is close to 30 miles. We also had 20. I mean, these are 8020, right? For those who are traveling. So here is just a screenshot of the various standards, right? I believe also as we speak, we have quite a number of standards, different frequencies, and so on. Now, typically in a wireless network, we have two modes. We have the infrastructure mode and we have the ad hoc mode. In a normal scenario, such as an organization, we normally implement an infrastructure mode. This is where a particular connected client within a network will communicate with a central device. Let's say you have mobile devices connecting to a wireless router. That is what an infrastructure mode contributes to. This mode doesn't allow two devices. We talk about peer-to-peer network, right? It doesn't actually incorporate the peer-to-peer network strategy where any device can be able to communicate with each other, right? So there's no direction, no direct connection between wireless devices, right? So what we are simply saying, infrastructure mode kind of incorporates the client server architecture, right? And not a peer-to-peer architecture. So this one, you need to have a central device. Now, in a peer-to-peer architecture is what we refer to as an ad hoc mode, right? So each wireless client connects directly to each other because they are kind of equal. So no central device is managing communication. Now, there are good part of this and also bad part of it. Ideally, if every well, if every device is communicating with each other, then that one creates an environment where security can be breached easily, right? So the other advantage is that if you want to set up a wireless network very fast, you do it in an ad hoc way, right? Let's say there's a building that has just been constructed, and maybe there's some meeting that needs to happen very fast. You can employ this kind of ad hoc mode, right? Now, we are now talking about security. And what I said is that there are quite a number of similarities between wired security and wireless security. The only difference is that in a wired network, we kind of monitor the media, the physical media, right? And see what is being passed through the physical media. The same strategy. If you can monitor what is being passed through the physical media, you can still do the same, use the same strategy to monitor what is passed through the wireless media. So all the security concept still remains the same. If confidentiality is breached within a wireless media, the same confidentiality can be breached within a wired security wired network, for example. So all in all, when you look at wireless security, we need to ensure that confidentiality, integrity, availability, we looked at all these, so you are familiar with what you're talking about, right? Accountability and so on needs not to be compromised. But what we say is that the main need of a network is to be able to transfer data or to communicate. And this communication happens either wirelessly or through wired means. So either you have some continuous signals or you have the medium such as the cables. So we need to protect these. Now the channel, as I'd mentioned, is the one that creates a good environment. People can be able to tap, eavesdrop into this. And we looked at Bob and Jack and the Maggie, the Judy person, right? We saw how they could be able to interact and someone could be able to tap into this particular channel. So what do you need to do to protect this channel? You can use different means, right? We looked at how you can encrypt, decrypt, and that is the same thing that we're going to talk about, but in a different angle, right? We have seen that in a wireless network, devices, you move from one point to the other. So this creates additional risk. Unlike the wired network, where once you leave the organization, you just go back to the same organization. When you're using your mobile phone, you're moving from one point to the other. So you actually increase the risk of being attacked. We also have the resources. We normally say resources are a means of how we can be able to distribute or rather get data, right? Now, if these resources are not well configured, for example, if they're not taken care of, we talk about resources, we look at them from the software perspective and from the hardware perspective, right? So you need to configure both accurately so that you don't mess up. When you connect devices within a wireless network, it's very hard to really monitor which device is authorized to access a particular resource, right? So you might end up giving access, or maybe unauthorized access might be realized within the wireless network. So these are just but a few factors contributing to the risks of network. What we have simply said is that when two devices communicate within a wireless network, there are quite a number of areas that might lead to attack, right? One, of course, is the Wi-Fi signals, right? You can see the endpoint or the end user device communicating with an access point. So in between, someone can be able to tap, eavesdrop, right? There are quite a number of things that can happen. That's why I said it's the same thing that we talked about, right? The access points can be compromised, right? Someone can have a rogue router and redirect traffic. So you think that you're connecting to the right access point, but you could be just communicating with the hacker. And of course, you also need to factor in the transmission medium, which is very, very important, right? We need to ensure that we reinforce security within this particular media that is used for communication. Now, in a wireless network, there are quite a number of threats. We have so far looked at denial of service attacks, identity theft, mark proofing. Now, when you are communicating, you have just realized or you have just seen that, like for example, the 802.11 participates within the lower layers of the OSI model, that is physical layer and data link layer. Now, data link layer, communication happens within the data link layer through physical addresses, and this physical address is what we refer to as the MAC, right? Now, what happens if someone wants to attack a local area network, or rather hijack communication within a local area network? They'll need to do what we refer to as MAC spoofing, right? Just having some kind of replica of the MAC addresses so that they can be able to maybe send broadcast stuff and redirect traffic and so on, right? We also have accidental association and malicious association. Now, accidental normally happens, even you, when you can always bump into some wireless signals and then you find yourself just you start browsing. You don't even realize that this particular Wi-Fi doesn't belong maybe to your organization. That is accidental. Now, that's a threat to both parties, both to you and to the organization, right? Because maybe the organization failed to reinforce their security. So by good chance, you decided just to log into their wireless network. But again, you can bump into some wireless network that is free, not knowing that these ones are just some kind of trap from the hacker. So you end up accessing a particular wireless. So that could be accidental anyway. You can do that. The same way applies to the organization, right? A malicious association is where now, as a user, you have malicious intent. So a hacker uses different ways to access this particular network. And of course, you have talked about the ad hoc networks, right, which are set up very, very fast, and there's no centralized device to monitor these. Man in the middle of attacks, we have quite a number. We have seen how you can use some kind of attacks, right? Someone can be able to plant a rogue access point in the middle. So you think that you're communicating with the right access point, but you end up accessing different, and so on. Network injection, where packets are being transmitted, and then they can create additional fake packets just to ensure that they degrade performance of the network, right? We talk about the TCP IP hijack, right, where you send a lot of packets to the network, rendering it useless. And of course, A lot of other additional threats can be seen. We talked about eavesdropping. So you can also bring about all the rest of the attacks or threats that we talked about. I think it was in our first lesson, right? They can also still apply within this particular wireless network. Now, to reinforce security within a network, we need to apply these three security approaches. In fact, they should be four, because there's a latest version, WPA3. Now, just like the standards of wireless network, the same applies to these security approaches. They keep on improving, right? Once you realize that there's some kind of vulnerability within a given protocol, I prefer calling them protocols, within a particular protocol, they actually reinforce or bring on board some latest version. WEP, if you remember from the standards, right, was actually invented or rather created within the 11B, right? And of course, you have the WPA that was brought about to really improve on the same. Now, let's just look at them one by one. So this was the native security mechanism, the WEP. It had a lot of security issues, right? But it was good. At least it could be able to secure the network a little bit, right? So it could prevent tampering the transmitted messages. It could prevent unauthorized access to the network, to the wireless network, to some point. You see, hackers or unauthorized users are also brilliant and they're smart. So they normally just try to work around measures of how they can crack this particular systems. And once they realize that there's some loopholes, they utilize that. And for the developers of these systems, if they have realized that there are loopholes, they bring on board another upgraded version. And that's what is happening here. So you can see WEP had a lot of vulnerabilities and flaws, but at least it played some role by then. Here, it used weak keys. I mean, the weak keys here could be easily cracked, right? So a hacker could be able to decrypt the messages, right? I remember there's a time that we could even just visit some website at some point, and with the SSID, we could just log into the Wi-Fi. It was really compromised, right? Now, it had the initial vector. The initial vectors are a form of just algorithm, but they were very weak, right? What was the downfall of this algorithm, or rather initialization of vector, was the fact that it was being reused. You see, when you reuse a particular algorithm over and over, I could always just go and use it and use it in another Wi-Fi that uses the same algorithm. So those are some of the weaknesses of WEP. So there are quite a number of tools that were used to attack WEP, right, as you can see. One was to actually monitor, or rather redirect the MAC addresses. We have talked about the MAC spoofing, that is MAC changer. We also have iwconfig, right? So it could put your wireless adapter, the NIC, into a monitor mode and fake the address resolution protocol. Address resolution protocol is a protocol that maps the MAC address to the IP address. So it was kind of a tool that just it was kind of filtering communication between the router and the network, or rather the local area network, right? So here, with the config, IW config, I could just place a rogue router, and all the MAC addresses from a network could point to my what? To my router, right? Because I could be sending fake RPs. And the rest, you can see we had aircrack, the tool that were used to to decrypt these. So what are some of the defense mechanisms that were employed? Of course, use of longer encryption keys played some magic, but not really. Also not having to reuse the keys or the IV, initialization vectors, all the time. So you could change it frequently, right? Use VPN, and also bring on board different encryption tactics. Now, it gave birth to a different or more advanced protocol, and that is the Wi-Fi protected access, right? Now, what changed there is actually the algorithm, because with Wi-Fi it used quite a number of advanced algorithms. We have WPA, WPA2, and WPA3. What changes is actually the algorithms that were used, right? Of course, all of these particular protocols use the cipher 4 algorithm, but how they were enforced or implemented were different, right? So this one improved the data encryption, stronger authentication, right? So it replaced, to some extent, the flaws that were realized within WEP. Now the same tools were also used, and additional ones were used to attack the WPA, right? So it was not that, we can't say that it was that powerful, right? So hackers found a way of actually also be able to crack this WPA. Now, the best strategy to defend in case of an attack was to use the passphrase complexity. What we mean by this is that the master key, the PM key, right, was to be made complex, so that when you use those particular tools, you could not be able to crack them. So this particular complexity, you can see the passphrase had a minimum of 20 characters and so on. But ideally, this was not that defense mechanism, a good defense mechanism. And that's what led to us using Wi-Fi protected access too. Now, these ones have a way of implementation. You can implement them at a personal level or within the enterprise. I don't know, but if you check on your Wi-Fi, if you click on that Wi-Fi icon, you can realize that you have a version. Mine, I think it is version, personal version, right? For the enterprise also they have theirs. Now, WPA2 had advanced security layers. As you can see, it used the advanced encryption standard algorithm, the AES, and in addition also it used the temporal key integrity protocol, right? So this one kind of provides some dynamic keys that were to be changed after some maybe login, and also it used the pre-shared keys for separate users. So it added a layer of protection to the network, and most of us, or most Wi-Fis, are actually using this WPA. I know there are quite a number of attacks on it, but it has some kind of immunity, right, based on the algorithm, or rather the encryption methods that it uses. So there are quite a number of attacks, as you can see, that it can actually eradicate right? So when you compare the three, as you have already mentioned, you can see the authentication, key distribution, and encryption and rotation. So this is what makes this one different. I know there's a missing three option here. Now W3 or WPA3 also has improved layers of security, but since we don't use it mostly in our networks, maybe I'll cover it sometimes in other lectures. Now, what are the mobile device security threats? We talk about wireless network. So what are the devices that we use? Because these devices are the ones that are used to compromise our network, right? So mobile device security threats emanates because of the lack of physical security control. You see, in a physical security, I mentioned you can always just bolt down and lock everything and you go. But for the mobile, you can always be jumping up and down. We talk about ubiquitous technology. Now, use of untrusted mobile devices, of course, these are just ways of causing or creating threat, right? Untrusted networks, apps created by known parties, everything within a wireless network, as long as it's a device that we can't trust, it causes a threat. So we can improve traffic security by using secured protocols, right? We can also use firewalls, right, just to root out these rogue devices. We can also use the intrusion detection system, intrusion prevention systems, right? We can also use this set of protocols, secure socket layers, for instance, the virtual private networks, you can employ them. For your mobile device, sometimes we say security lies on the user, the end user, right? So you need to ensure that how your mobile is set up also is appropriate, right? Because someone might need to crack a Wi-Fi for an organization, but they might not be able to do that. So what they might do is to check the connected devices and see which one has some vulnerabilities. It could be your mobile phone, for example. So they can use that to connect to that particular Wi-Fi and cause some problems. So what you need to do is just to have some configuration, as you can see, right? Apply some kind of policy procedures. We have already created a policy, so you know what a policy is. Install some antiviruses, update your, if you have some SSL, configure them, right? So that at least you avoid being part of the problem to the wireless network. Now, since most users doesn't understand the problems that they might cause to the network, it is always the responsibility of the organization to provide tools, training, right, so that at least they secure their wireless network. Because if you leave it to the users alone, with them they don't care. After they have messed up your Wi-Fi network, they'll go and use another Wi-Fi and you're left there, right? So you can use some kind of a firewall. You can use some control mechanism, authentication servers, just to monitor, right, which device is not part of this particular network. You can provide some encryption tools, allow your devices, every device, to connect via VPN, for instance, when they are using the organization network, and so on, right? So when you secure the network, we have said you can always turn off this broadcasting of the SSID, change the default root ID. When you configure the router, that's why I say that it's the first vulnerable point. You need to change a lot of things, and you also apply MAC filtering, right? If you get a chance of doing Cisco, you'll be taught how to configure the access control list so that you do the right filtering. It's a very interesting concept of how you can actually secure the network. And of course, you can enable the pre-shared key just to ensure that you isolate the signals that are being used by unauthorized to come and get access to our wireless signals. What are the countermeasures? We have so far mentioned a lot of these countermeasures that you can apply, right? We are told that you can use some special paint. I was trying to do some research on this special paint to stop radio. Maybe the radio waves, right? We talked about the houses with something proof, noise proof, right? So if you are serious, you can also have that, some radio proof, so that your signals, the broadcasting of SSD doesn't go past your building. We have said that you also allow only the MAC addresses associated with the. We have talked about the address resolution protocol, right? MAC addresses and the IP addresses. Use authentication server. Also use the anti-war driving software, right? Anti-war driving softwares are very many, and also the war driving softwares are also many, right? Of course, you can configure the honeypots. You can have the honeypots, right? You can also have these other softwares that can always create some fake access points. You see, when hackers are trying to get into your network, you can create some dummy or some kind of honeypots that trick the hackers into getting maybe access to those particular. It's like you drive them off your network, right? We are going to look at the word driving, so just a minute. Of course, ensure that your access points are placed in some perimeter wall. We talk about the demilitarized zone. Now, these are kind of a no-go zone, right? So they're very safe, right? So these are an area isolated to very important things. So in the military, they talk about an area where no one should be able to go to, right? So you can use that particular area so that you only have your access points. So no any other device. So you can always have some kind of shield. Anyway, you can also use encryption, as you have seen. Use antiviruses. Turn off the identifier broadcasting. Change your router's preset. Do all these just to enhance security. Now, what is word driving? Because this is a mechanism that most people come use it to exploit our wireless network and go ahead and compromise it, right? Word driving simply means looking or getting access to some kind of wireless networks with an intention of actually creating or causing some form of attack. So when you drive, you can drive using a bicycle to a wireless point, a wireless network. You can use the aeroplane. You can use a car. That's where the driving comes in. So it's actually not legal for those people who go to access this particular. But if you use this strategy in a wrong way, then it can cause a problem. So we are just interested with the hackers who use word driving as a means of accessing what? The wireless networks, right? So it works simply by you having some laptop, wireless, an antenna, and a software that can be able to scan. And that's why I always say, for those of us who rush to just log into some wireless networks or Wi-Fi, for instance, you could be logging into some attacker access point, right? And before you know it, everything is gone, right? So they come with some software that scans, right? So this antenna that they use, also they know where they can always purchase them. They are of different prices. Of course, the more expensive it is, the far it can capture the different SSIDs. Now, when they use these particular softwares to scan, they can capture the SSID, which is very, very crucial, right? They can also discover the type of security that is enabled. Is it WEP? Is it WPA1, 2, 3, or so on, right? And of course, the signal strength, right? So these particular softwares that they use for word driving are quite sophisticated. So you can check on these sites. There are quite a number of tools or network tools. Now the good thing is also you can also use these, not in a bad way, but also to discover those rogue or those access points that are being planted. You can also use this tool. That's why you normally say that we have hackers and ethical hackers. You see, the same tools that hackers use are the same ones that a professional ethical hacker will use, right? So you can still use them just to enforce your security. The more widely used is the net scrambler. It supports quite a number of Wi-Fi standards, right? So it's designed to do some wireless LAN configuration, detect unauthorized APs, right? Now you can always also go to another angle of connecting it to the global position system so that you can map a wider location, right, of these particular APs, right? So it logs the following information we've already seen, which is very crucial: MAC addresses, the channel, the signal strength. So that is net sampler. We also have Kismet, right, which also does the word driving attacks. It runs on different operating system, as you can see, right? So it's also advertised also to sniff different ID, and of course it can work within the different wireless standards. You can see there B11, A11, and G11 traffic. Features: it does some graphical mapping of networks. It also can be configured within a client server architecture. It supports more than 25 card types. Those are the NIC. Detection of non-default. Every tool has its own features. So it depends with the kind of threats that you are going through. Hacking a wireless network is very simple, but also it can be very difficult if it is well secured. So you can do port scanning, right? Port scanning entails a lot. You see, port is an entry point to a network using the protocols that are not secured, right? So if you're not using the proper secured protocols or network protocols, then chances are port scanning will work. Enumeration is another one. We have talked about MAC spoofing, right? Enumeration is simply just kind of listing or extracting some vital network information. It could be from a wireless point of view or wired point of view, right? So this will enable, enumeration will enable them get the much needed data. And of course, the tools that mostly they use is a laptop, right? Especially when you go to these coffee joints and you see these gentlemen are very busy with their laptops, you might think they're doing some very nice work, right? Because they know that those are the joints that people come and maybe start doing some transaction, right? And they also need to have some sniffer software. So ideally, that is all we can talk about regarding wireless network. We have looked at the various attacks, technologies involved, the various standards, and of course, how you can use the tools to maybe protect yourself.